Now let's look at one-tail tests. One-tail tests are where your alternative hypothesis is strictly less than a value or strictly greater than a given value. Okay, it is not equal to. So the alternative hypothesis is not equal to, then it is a two-tail test. If it is not equal to, then it is a one-tail test, and the critical value will the direction of the critical value of the tail is going to be the same as the alternative hypothesis. If it is less than, then the rejection tail is on the left side. The critical value on the rejection tail is the lower tail. If it is greater than, then the critical value and the rejection tail on the upper tail. And similarly, if you want, when you compute p-value, then you need to look at only one tail, not two tails. Like in the two-tail test, we multiplied by 2, whereas here we just keep it as one tail. And we don't divide alpha by 2. So here, if you have a test like this with the left side tail, we find the z value of the entire alpha. We have only one tail to consider, not two tails. Whether it is z or t, in either case, you put all of the alpha in the tail, and if it is a left side tail, it is a negative value. Okay, and if it is on the right side, it will be the positive value with the whole tail. So here, if it is greater than, then it's all the alpha here, not alpha over 2. Okay, and it will be the positive z sub alpha or t sub alpha. So here is an example of sigma unknown. It's a t-test. Okay, and a one-tail test. A phone industry manager thinks the customer monthly bill now averages over 52, and we want to see whether that is true. Over 52, so greater than 52 is what we want to test and attest to. So strictly greater than, over 52. So it is not greater than or equal to. Okay, it is greater than 52, and that has to go in the alternative. So that goes in the alternative. So the null, oftentimes it's easier to set up the alternative first. Instead of starting out with the null, you start out with the alternative. Now, once you fix the alternative, then the opposite is the null. And in a one-tail test, this is especially true. So in a two-tail test, it is somewhat easier. In a one-tail test, it is convenient to set the alternative first and then set up the null as the opposite. So rejection region here for alpha of 10%, suppose that chosen alpha is 10%, then you find the t value. So here sample is 25, so degrees of freedom is 24. So find the t value for upper area is 10%, which is that. Upper tail is 10%. Okay, 24 is the degrees of freedom. So you get 1.3178. So here it is. So if the t is in this area, we reject, otherwise we don't. So if sample gave us an x bar of 53.1, so 53.1 minus 52 over s over square root of n gives you 0.55, and the 0.55 is less than the critical value, so it is not in the rejection region. So we cannot reject the null hypothesis. If we reject a null hypothesis, then what will be the p-value? So we can compute the p-value and then say that would be the probability of type 1 error. Too large for us to take a stand. Okay, the p-value here turns out to be almost 30%, 0.29. That's too large a risk for us to go in the limb and then reject.